We always struggle with our impacted canines. We give us a lot of problems by choosing which kind of path and treatment we should apply. So what I've done is I used what we call the Dijkstra algorithm, which computes the shortest distance with the less risk into a canine, which is right here. So if you look at the canine position, we start with this. This one is again just a rendering, so obviously without any surgery. This is not feasible, so we do first surgery. Takes a month. The risk factor is only 1, and the complexity of treatment depends on the position of the canine, so it's got a 2. Then we have this surgery has been performed right here, and then we decide to go with the crown and do an initial distalization. So basically we go to the red, we expose, we go to distalization. Then we have 2 paths that you can see right here. So we can try an early torque application called risky. See, the complexity is 5, the risk is 4, so that would be probably the wrong idea. You may have more than 2 paths, by the way. This one takes 4 months, it's longer, but the risk factor is still 3 and the complexity is 4. So you can see for impacted canine, the algorithm just tells us that there would be no easy treatment. We could probably incorporate one with a longer treatment time and less risk. So it's up to the practitioner. So then we have distalized, then the canine has been distalized 5 millimeters to avoid the lateral root. Again, depends on the complexity. This is synthetic data, okay? And then we go to this position here. So then the root apex is clear. We have an initial alignment. We're happy. And then again, the risk is now 1 that you are going to be aligning the canine onto the arch right here. There is a bit of an overlap. I do apologize. And then finally, you apply the torque. So this is only one of possibilities, and that's the simplest one I could find. But you can see that there are multiple nodes. This is called a node, where you can add nodes saying is it going to be a closed exposure, a open exposure? Do I distalize first? Do I try to torque first? So every time you are entering in this code that I built, you will have a different time, a different risk, and a different complexity. So this is basically what is going to be used in a machine learning environment to help better understand the most efficient and appropriate treatment approach for impacted canines. And obviously age, angulation, all these have not been yet incorporated, but you can see immediately how complicated this can become. And that's why we need machine learning or significant practitioners' experience to compensate for these complex concept of just pulling on the tooth is basically not enough. Thank you.